Perfect.
Great.
Finally.
Finally, yeah,
Yes.
sorry for all the...
No problem. This is my first time ever. I think might be the last as well doing this on Instagram. So thank you so much for joining today. I'm so happy that you were able to be with us today and talk about the wonderful work that you and your team do every day. So
Yeah.
let me just briefly for everyone watching. This is an interview that we are conducting as part of the boot camp organized by FAO and the Future Food Institute. So this is a group of people around the world with different backgrounds, scientists, CEOs, entrepreneurs, startups, different kind of backgrounds there from different countries. And all passionate about sustainability and understanding and learning how each one of us can contribute to advance the sustainable goals from different perspectives, from everything that we do. So that's kind of like why we are doing this. And for those who don't know, my name is Yulie Meneses. I am a research assistant professor at the Department of Food Science and Technology and the Water for Food Institute at the University of Nebraska-Lincoln. My work is developing strategies, sustainable and accessible strategies and treatments for wastewater originated from the food industry. So today I have invited my friend Paola. She is part of Microterra, who is also a startup that is working on using microalgae for the treatment of wastewater. And I'll let her introduce herself and explain a little bit of what they do. Thank you, Paola.
Thank you, Yogi. It's very nice to be here and having this opportunity. Well, yeah, I'm Paola Constantino, and Microterra. I'm the CSO, the Chief of Science in Microterra. And we are a startup that does biotechnology, but our mission is mainly to save the water. And it all started because we want to prevent all the excess of nutrients coming from the agro industry going to the ocean and causing all these catastrophic algae blooms and all that. And the way we are doing it right now is we are using microalgae to clean the polluted wastewater and recover those nutrients that are the pollutants and producing a valuable resource. No, it could be an ingredient for feed for animals, or it could be other things like biofertilizers and things like that.
So so we have people from different backgrounds. Can you explain a little bit why are you using microalgae and what are you targeting wastewater?
Yeah, well, I will start with the second question. All the idea of the mission and why the startup started at the beginning is because the founder, Marisa Cuevas, was once in a talk from the NASA, and there they were saying this forecast about the Third World War being about water. And she's very moved about solving or trying to contribute to this big problem, like water is one of our main resources. And that's why she started to look for possible solutions, how she could help to solve this. And she found that microalgae, for example, they are one of the fastest growing microorganisms in the world. Like they doubled very fast. And also there are a vast variety of different species there. And they have evolved thousands of years to adapt to living in these pollution conditions. Like, for example, all these rivers that you see that are green and with different concentrations, let's say, of nutrients and things like that. And that's why we choose microalgae. And and also because they have very interesting compounds, depending on the ones you are using, that could offer not only this potential of cleaning the water, but also will be a interesting byproduct.
Yes, so microalgae, actually has the potential to absorb nutrients like nitrogen and phosphorus from the wastewater. And those two components are the very same that actually cause eutrophication, right? That's the biggest when you see the alga bloom, that's what's happening. So actually, working with wastewater and using microalgae is pretty an inexpensive treatment alternative, right? Microalgae grows widely, and wastewater is providing the nutrients that they need to grow. So tell us more about like the solution. So now we know wastewater is a problem. We know that microalgae can remove these nutrients that can be pollutants into water bodies. But how does what did you create it to solve that issue?
Yeah, well, before that, for example, I would like to say that we are focusing on the agro-industry wastewater, not all types of wastewater. So why? Because when doing the research about, okay, if water is a problem or will cause a terrible water, why? And then we discovered, for example, that agriculture is actually the biggest water pollutant. So mainly because of the intensive use of fertilizers that run off into the water, and also because all the animal manure that our current food systems are producing, no? And so going from there, we say, okay, so the solution needs to be, or at least in our solution, in the way we want to solve it, needs to be decentralized. So we can target different spots from agriculture that are actually occurring and prevent the pollution before it gets to the river. And we are also using right now we are in Mexico, and the solutions we are developing are thought to be used mainly in tropic conditions, probably Latin America to start. Why? Because we can harvest then the sun and all these nice temperatures for the microalgae. So the solutions are think to be like in a cost that will be affordable for farmers, like middle scale to large scale, and also are thought to be not depending on chemicals. For example, we are harvesting not depending on chemicals and also not very energy intensive. For example, we are using a technology that allows to do the harvesting of the microalgae in a very efficient cost and energy and like organic way. And
Sure.
also, I think one mainly interesting point about our technology is that we are also selecting microalgae that are already adapted to the eutrophied rivers. So we are not using GMO or things like that. We are using just the selective biology is called, so the microorganisms that have naturally evolved and that are accustomed to growing in these. One might say that these are very tough conditions for growing, no? Yeah. So that's the main thing we are doing.
Yeah, and then I know that you, from our previous conversations, because I have talked with Paola many times about the work that I do, and how in my case I develop some of the science behind, and she goes and apply them there in the real world. So that's how we can complement each other. So I know that you have a farm that is using your technology in Mexico, and it's an aquaculture farm. So can you share a little bit about like how are they using your technology and why is it something that it's important to them?
Yeah, so when finding that agriculture is one of the biggest pollutants, then we say, okay, if we need to start, we selected aquaculture because then the wastewater is already in a pipe and it's easier for us to just connect the reactors where we are growing the microalgae and start from there. Also, is because we choose that type of wastewater because there are not other like pollutants like hormones or probably other than in sewage we will find, no? And in this farm, this is a tilapia farm that is a fish species mainly like widely cultivated here in Mexico. And basically what we are doing with the farmer, he's like a very, I would say, active in this sector of innovation in the agricultural sector. Like he's very open to ideas. So he find, oh, if I can make in any way a circular system, he find it very nice because he's also cultivating like strawberries and other types of cultures there. So in the way that we were capturing the wastewater coming from his ponds, we were at the beginning using this algae for his plants, but now we are in the process of also, not also, but instead of doing it for biofertilizer, trying to explore ways that we could feed also the tilapia there. In this way, we are contributing, for example, to reduce the water they are using, at least eliminating any type of wastewater, since it is a circular use. Like the water comes out, we clean it in 3 to 4 days, and then the clean water and with more oxygen because of the photosynthesis goes back to the tank, and the microalgae is harvested for, yeah.
And then so the microalgae in this case is a byproduct, right? It's a valuable byproduct that, so microalgae is not new to the world. It has have many years been around, the technology. At some point it was thought that would be an alternative for biofuel production. But in your case, you're using this as an animal feed. Is that right?
Yeah, we are right now doing all the things that we need to do in order to be able to use it as an animal feed ingredient. Like one is, of course, ensuring that we have enough algae produced, one amount that is enough to feed the tilapia in the pond, and also all these technicalities about compliance and getting the cost good enough to be profitable and things like that.
Sure, definitely. That's one of the main drivers, right? Like the idea is that you want to bring this technology down to a cost that is actually accessible, right? It's not like these big complicated technologies that use electricity and a lot of energy intensive, right? Like these are technologies taught and designed in a way that can be easily implemented at the farm level and under the circular economy concept, right? Like you take the water, you treat the water, you put back the water into the system, you harvest the biomass, and then you use the biomass for something else. As she said, it might be fertilizers. Biomass can be used as an animal feed, hopefully, depending how, like making sure that it is safe for animal consumption. And another thing that myself included, are exploring is the use of biomass as a source to produce bioplastic. So those are like some of the biggest, like great alternatives. It's just people don't think about treatments are possible in this sustainable and low cost way, but they are, right? Like Paola is actually demonstrating us that it is possible to do all of that. So Paola, can you tell us who is part of Microterra? Is yourself, you mentioned the lead. Who else is part of your team?
Yeah, well,
and what is
the founding team is mainly composed about very, I would say, passionate women. For example, Marisa Cueva, she's all about garbage. Like she wants to use and create value from there. And she's the CEO. She studied in Columbia, master about sustainability, and her background is about energy engineering. So that's why sometimes our business, well, not sometimes, always our business models are very familiar with the ag sector. And our COO is Fanny. She's the only one with main experience about all these administrative and business things. And we also have other technical team, like for example, Marla and Victor and Hugo, and they are in different parts of the core business, like developing the science back in the lab. And Marla is also doing all the interviews with aquaculture farmers, which is very important because at the end they are the clients. So cultivating all these relationships.
So I'm just gonna say here, like from the people that are watching this right now, please drop your questions there, if you have any, so I can ask Paola. But another question that I wanted to ask is how long have you been in this journey? Because it's been some years now, I think. But can you tell us how long and what have been the most difficult challenges that you guys have faced going through these as entrepreneurs, as startups, young people, women? There are many challenges, I'm sure, that you guys have to
Yeah,
face
well,
during this time.
we are tapping into a very a difficult problem, mainly because you cannot see pollution. So, and also in Mexico, at least, there are no fines that are enforced. So people is not driven by or driven by not getting fined and solving the problem of discharging the wastewater, no? So that's not a problem. So it was very, at the beginning, very finding the sweet spot, how we can sell this message to convince people to believe in the idea, to get on board on the project. That was one main challenge. But once you find the people that also believes in those types of solutions, like innovation, biotechnology, saving the water, or just having a better place to live, then it becomes more easy to, for example, to go and go from an idea to an actual project, a proof of concept in the lab, and later on a pilot, no, with this farm. And the second challenge, I will say, it will be, for example, navigating the agricultural sector, because it's mainly dominated by men, and we are all women and very, let's say, young. So it was difficult these girls are coming to my farm and are trying to explain me how to do things, and so it was very thought process of learning, and finding the right channels to how to get to them, and and nowadays I think the last challenge we are facing is, for example, so we are trying to join two different parts. For example, one is the aquaculture, and the other one is the one who at the end will buy the algae biomass. Could be the farmers, but could be also the animal feed industry or other industries. So they are two different, I will say, worlds, two different channels of language, of how you communicate and how all the things you need to prove. So it's very interesting, and we are learning lots of skills. For example, how to truly prove what you believe and the science you are doing in the lab. Yeah.
So when did you guys start it? When was the first time that you thinking together?
Like the first time that we started was about 2.5 years ago, like from scratch, from zero to what we have now. And right now we also, for example, develop, we have a part of the team that is also developing bioinformatics. For example, we couple our technology or the reactors with sensors, different sensors that measure, for example, all the parameters, pH, temperature, and other nutrients. So we can, for example, model and even forecast when the reactors need to be harvested, when there is a problem or a breakdown in the reactors, or also helping the farm to maintain the water quality in the ponds, no? So
sure,
it's so it has been 2 years of a lot of different areas of learning, getting all the samples from actual polluted rivers, of microalgae and things like that.
So this is a question that a lot of people have is how do you keep this going? I mean, where is the funding coming from? And it's been 2.5 years, and you have done a lot of research. Research is usually, I will say for sure, expensive to do. So how you guys are handling that part?
Well, I I think it mainly goes with two things. One is one key was finding the right people, at least in the team. All of us are very passionate, so that helps. For example, even when we find a lot of challenges on the way, or also for sharing joy and passion, that keeps the thing going on, because we are mainly going for saving like the water. Like, it could sound a little bit idealistic, but also it helps moving on the wheel. And also we have been, for example, bootstrapping the company with grants. So it all started with a grant from National Geographic. That was the first grant we got, and that started, okay, now we have an idea that needs to happen into a real project, so let's do it. And then also we find, for example, a grant from the government from one state of Mexico that was in those times investing in innovation and biotechnology. So that was also key for finding like money that do not cost capital. And the other thing was that has been very helpful for us is through partnerships. For example, we have a partnership with one of the leading institutes of Mexico for research. So that helps us, for example, yes, research is very expensive, but when we have those partnerships, we can somehow lower the cost of research. And for example, we have also let's say a partnership with Amazon through a startup program they have that help us to develop, for example, in a very affordable way, all the bioinformatics and the algorithms and things like that. So yeah, finding the right partnerships has also been very important for us. Yeah.
That's awesome. That's awesome. So then the question is, what's next? I mean, what are the plans for the future? You know, like where is Microterra going? Are you gonna keep, growing this microalgae world, or do you plan to move to a different technology? What's the plan for the future?
Well, it's a tricky question now in the times of all this uncertainty. At least we are convinced, for example, with the team, that our mission is to clean water from the agroindustry. Right now, we are going into this process of reassessing the market. We have a solution. We have all these bioinformatics, all the models, the microalgae, but we are also trying to better understand the industry. For example, if we want to sell the animal feed, then we are conducting all these interviews, just popping up through internet and emails, all these interviews to find out, okay, if we want to do it that, what do we need to achieve? And also we are conducting with all the aquaculture farmers, not only tilapia, but also other species that are very widely cultivated here. So to finding, is microalgae the only solution? And I think we will find out what you are exactly asking, like what's coming like in the next months. Like, we could produce microalgae, but I think the solution, but that's only my opinion, it will not necessarily be the whole team, that it will be, for example, a combined solution, microalgae and something else to really make it viable. Yeah.
Definitely. And that's like my research theme as well, like my idea is also related, even though I focus mainly on wastewater from food processing. Yes, I think that it has to be a treatment train, like something that is complemented with other things, especially because in my case, my goal is actually to clean the water to a level that we can reuse. Because if you think about the sustainable goal, number 6, that is related to water, actually what they are looking for is not only the reduction and optimization on the use, but also increasing the reuse of wastewater. That's something that it's coming to all the people looking at this, watching this. wastewater reuse is not a bad thing. It is possible to do in a safe way using the technology that we have available. So and Paola just walk us through a technology that is doing that in a safe way. So it is possible, you know, like we have the technology out there. We just have to apply it. That's from my perspective. That's what I see.
And also, I think, for example, how we met is something that will keep happening in the future, not only with us, but through all the people working on trying to solve these wicked problems. It's like a lot of collaboration needs to happen, and I see all that happening in the future. Like us, for example, collaborated with different parts of the industry, or collaborating with other people that has already done a lot of impressive work in different arenas that we need to like put all together and really create a valuable product for the people. Yeah.
That is true. That is true. Well, I think, let me see if I have. So like the last question that I have for you is, can this be applied to other types of wastewater? Or you say you're going to start with aquaculture. Can we take the same concept and go in a different sector, you know, like another sector from agriculture, like beef production or...
Yeah, well, it's I think once we solve, for example, some key steps, for example, all the pathogens that could somehow, if not designed well, represent a certain problem, that could limit the applications. But in fact, we are actually working with a cow manure project. So yes, the technology could be applied to different types of animal manure, and also could be applied, for example, not only to animal manure wastewater, but even the incoming wastewater, the incoming water that is used in aquaculture or in other types of agriculture. Why? Because when we were having these interviews recently with different people working on all the different stakeholders involved, we discovered, for example, that more recently, all the sources of fresh water or a lot of rivers are already polluted. So the algae, not the good ones, or at least like a wide variety of different organisms are already polluting there, or a lot of fertilizers are there. So I think it's also a possibility to treat the fresh water, not only the wastewater, but the fresh water.
Definitely, that's another alternative. If they can clean anything that has nitrogen in it, so nitrates can be, pick up by the algae. Doesn't necessarily has to be applied to wastewater, but maybe another way to produce, to improve the quality of surface water. Let's put it in that way. Or groundwater. Sure.
Yeah.
Well, I think that we are like closing up with that question. I just want to say thank you so much, Paola, for taking the time to share with us all the wonderful work that you guys do in Microterra. We wish you the best on the future endeavors and the future projects that you guys have planned. So we will continue talking because I'm sure we will collaborate.
Yeah. It's always nice to get to know all the projects that you are working also with, like all the types of wastewater. And so thank you for this nice invitation. It has been a pleasure.
Thank you so much. Thank you so much. Thank you, guys. Well, until I talk to you next time. Bye-bye.
Yeah, hugs. Bye.